This video is the continuation of properties of adjoint of a matrix and determinant of adjoint of a matrix. It is very, very important in JEE Main and JEE Advanced. Since the video becomes too lengthy, that's why I have divided into two parts. One part is completely theory, another part is problem discussion from previous JEE Main. So once again, I'll rewrite simple properties of this adjoint of a matrix and determinant of adjoint of a matrix. Assume that A is a 3 by 3 matrix. A into adjoint of A equal to, we have that A into I. You please watch the previous video to understand the proofs of these all points. Second point is A inverse equal to adjoint of A by A. Third point is determinant of adjoint of A equal to A whole square or A whole power n minus 1. Here I am writing A equal to, it is an n by n matrix. So simply I will write the matrix form n by n. This is if A not equal to 0 and 0 if A equal to 0. The fourth point is that what is determinant of adjoint of A. So this is equal to A power n minus 1 whole square. If you want the proofs of this, please watch. There is another video based on properties of adjoint of a matrix with complete proofs. Fifth one, suppose if there are 3 adjoints, which means that adjoint of, and so on. Suppose if I take K adjoints, suppose if I take K adjoints, like this. So here you assume that there are K times, adjoint repeats K times. So this is equal to A power n minus 1 whole to the power of K. This is very, very important. And determinant of some Ka equal to, you remember, this is K power n into A. Seventh point is determinant of AB equal to, you can write directly A into A. Eighth point is, these are the only prerequisites to solve the questions. The eighth point is that adjoint of AB equal to adjoint of B into adjoint of A. Adjoint of A. These are the most important to solve the coming questions. And remaining, any other concept is there that can be derived from the basic concept that A into adjoint of A equal to A into I. and here determinant of A inverse equal to, this is 1 by det A. So wherever A inverse exists, we assume that det A not equal to 0. So this simple, you can say deductions or properties of adjoint of a matrix will play a very important role. Now I'm going to solve a few questions based on these concepts. See here, this question asked in JEE Main January 2023. Let A be a 3 by 3 matrix such that determinant of adjoint of A. See how many adjoints are there here. We have a 3 adjoints. So solution. Solution is quite simple, that determinant of adjoint of A. In fact, I need not to write many a times. So here this is 3 by 3. So using our formula, this is equal to det A power n minus 1. Here 3 minus 1. This is whole cube. Number of debts is 3. So here you can see. Just is here. Det A whole to the power of n minus 1 k. If there are k adjoints. So this is equal to det A to the power of, it is 8. Well, so now question is very simple. So this is given as 12 to the power of 4. So therefore, det A equal to power 8 equal to given as 12 to the power of 4. This implies det A equal to, it becomes root 12. This is root 12. 12 to the power of 4 by 8. Now they are asking what is determinant of A inverse into adjoint of A. Now, determinant of A inverse into adjoint of A equal to, you can write det of AB equal to det A into det B. So this is det A inverse into determinant of adjoint of A. Now use the properties. So this is nothing but 1 by det A. And determinant of adjoint of A 3 by 3 is nothing but det A whole square. So this is simply det A. So this is equal to root 12. So we got 2 root 3. They can't ask more easy questions than this. So this is a very simple question. Everybody can solve it. They have asked a very simple question based on properties of adjoint of A, that is determinant of adjoint A times. If you can remember this formula, you can find 15 to 20 questions in previous JEE. So coming to the next question. So here is another question asked in January 2023. Well, A is an n by n matrix such that det A equal to 2. If the determinant of adjoint of 2 times of adjoint of 2A inverse is 2 to the power of 84, then they are asking this time what is the value of n. Well, so here you see, what is the determinant of adjoint of 2 times of adjoint of 2A inverse? This is the question. they are asking. Okay, so this is equal. Assume that this is some matrix B. Assume this is some matrix B. So it becomes that adjoint of B. So B is a n by n matrix. So you will have this is det B whole to the power of n minus 1. Well, now what is det B? So here you see what is det B. Determinant of B is nothing but 2 times of adjoint of 2A inverse whole to the power of, right, n minus 1. So here this that I have substituted that B matrix. B matrix is 2 times of adjoint of 2A inverse. This is equal. Now further this is equal to, you see, you bring out this 2. A is n by n matrix. Okay. So this is 2 to the power of n, right? Whole to the power of, here n minus 1 power is there. N minus 1 into determinant of adjoint of 2A inverse whole to the power of n minus 1. Further, the first one becomes 2 to the power of, this is n square minus n. Here you see, again you apply that adjoint of a matrix, determinant of adjoint of A. So this is, in place of A, we have here 2A inverse. So 2A inverse whole to the power of n minus 1. Again whole to the power of, here another n minus 1 is there, power. Right. So this is equal to, 2 to the power of n square minus n. Here you see, this I can write determinant of 2 times of this determinant of A. Okay. So this is nothing but 2 times of A inverse whole to the power of, here n minus 1, here n minus 1. So I can write n minus 1 whole square. Now bring to this, bring out of this, bring 2 out of the determinant. So this becomes 2 to the power of n square minus m. Okay. So using that det Ka equal to det into K, A n by n matrix equal to, we have that K power n into det A. So here K is 2. So we'll have that 2 to the power of n whole to the power of n minus 1 whole square, because here power is there. Determinant of A inverse whole to the power of n minus 1 whole square. This is equal to, here we have, this is 2 to the power of n square minus n. 2 to the power of, here this is n into, this is n minus 1 whole square. Determinant of A inverse is nothing but 1 by det A. So this is 1 by det A power n minus 1 whole square. So I'm doing this question further here. Okay, this is equivalent to 2 to the power of n square minus n. Seems to be little lengthy calculations, but still question is simple. Whole square. Here det A value is given as a 2. So this is 1 by 2 power n minus 1 whole square. Now it's all left to simplify the power of 2. So it becomes 2 to the power of, here you see, n square minus n plus n into n minus 1 whole square. Here this is, you can write minus of n minus 1 whole square. Further, 2 to the power of, the first one is, you see, in all these, you can take one n minus 1 common, or I can write here. Here n minus 1 take common whole square into n minus 1 whole square taken common into n minus 1. Further, this is equal to 2 to the power of, you take one n minus 1 common, then you will get n plus n minus 1 whole square. Given that this is equal to 2 to the power of 84. Now the point is, if you equate the powers, left side you will get that cubic equation in n. Cubic equation in n. So sometimes it is very tedious to solve the cubic equation. But here n is an integer. Here n is an integer. So either you can give the values for n equal to 1, 2, 3, 4, and so on, so that you will get the answer very simple. So if I start from n equal to 2, so it is a trial and error method. So substitute n equal to 2, right? Then what becomes LHS? LHS equal to 2 to the power of 1 into, this is, it becomes only 2. So this is not at all 84. For n equal to 3, that LHS equal to 2 to the power of, it is 2. So this is, and here this is 3, because n equal to 2. Now when n equal to 3, here 2 into 3 plus 2, that is 5. So this is not 84. For n equal to 4, that LHS equal to 2 to the power of 3 into, it becomes 4, right? And just a minute, when n equal to, this is 3, 2 square 4, and 4 plus 3, it is 7. So this value is 7. So this is also not possible. It becomes only 2 to the power of 14. Now when n equal to 4, this value is 3. So here 4 plus 9, 13. So 13 into 3 is just 2 to the power of 39 only. So this is also not possible. We want that 2 to the power of 84. So at last, I think that for n equal to 5, LHS equal to 2 to the power of 4 into, right? This is 5. 5 plus 16, 21. So this is equal to 2 to the power of 80. So hence, n equal to 5 is the perfect answer. So instead of solving that cubic equation, when for an integer value, better you substitute like this. Here is another question asked in January 23. This model is very, very important. A is given, and they are asking what is determinant of adjoint of A. So first, let us write that what is determinant of adjoint of A square. So here we have two adjoints. This is equal to determinant of A square power, we have n minus 1 whole square. So which means that 3 minus 1 whole square. This is det A whole square, and this is 4, so becomes totally power 8. So we want that det A whole power 8. So now what is determinant of A? So here is the determinant of A. A equal to determinant of or we want that det A. So this is equal to determinant of. I can write the first one as, or I'll write this. This is one. The first log y base x, I'll write log y by log x. Of course, you can expand in fact directly also log x. And log z base x, I can write log z by, this is also log x. Whereas second row, that log x by log y. And this is 2. Next one is log z base y. We can write log z by log y. Third row, it becomes log x by log z and log y by, this is log z, and last element is 3. We need to expand this determinant. So here you see, from first row you take log x common. So I'll write that outside log x, or multiply the first row by log x. So here you will have log x, log y, and this is log z. This is from first row. Multiply second row by log y. Multiply second row by log y. Then you will get here, you see, this is log x, and this is 2 log y, and this is log z. Well, now for third row, you multiply with log z, or you take log z common. When you are multiplying something inside for a row or for a column, you must divide outside. So here you will have log x, this is log y, and 3 log z. Once you get this idea that log y base x can be written as log y by log x, means log a base b equal to log a by log b with any base. So now you see, this becomes very simple now. You take that log x common from this first column, log x common. From second column, log y common. From third column, log z common. Here, log x you can take an out. From second column, log y common. From third column, log z common. So you just take out. Now you see, this is equal to log x taken out from the first column, log z into, this is log y and log z, whole by log x, log y, log z. So now determinant reduces to very simplest one, that determinant of, here from first column we have taken log x common. So here 1, 1, 1. Here second column 1, 2, 1. Whereas third column 1, 1, 3. So now these terms cancel. So now expand this simple determinant, that 1 into 6 minus 1, that is 5. 3 minus 1, 2, minus 2. And this is minus 1. So this is equal to, you will have 2. So det A equal to true. So now what is the answer? You see here. We want that det A whole power 8. So substituting that value is here, you will have that 2 to the power of 8. So only the point is they have linked with finding determinant of matrix. Here is another question asked in January 2023. Okay. P is a 3 by 3 matrix satisfying P transpose equal to AP plus A minus 1 into I, where A is greater than 1, asking what is the determinant of adjoint of C. Okay. So here the basic logic is that we need to find out P. We know that here you see that P transpose they have given as A into P plus A minus 1 into I. It is just solving of two linear equations, but they will be given two linear equations, means in terms only in two variables x and y. But here they have given only one relation, that is P and P transpose. But we can bring another relation by taking transpose on both sides, right? So here taking transpose both sides, taking transpose. So let us take transpose both sides. See here P transpose whole transpose equal to right side AP plus A minus 1 into I whole transpose. This is equal to A into P transpose, and left side it becomes only P plus A minus 1 into I transpose is nothing but I. So here we have used that A plus B whole transpose equal to, we write A transpose plus B transpose. Okay. So here we got another equation. This is 1, you can say this is 2. So substituting P transpose value from 1 in 2. So this implies substituting that P transpose matrix into, from 1, what is that P transpose? See here, A into, okay, P transpose is nothing but AP plus A minus 1 into I, and plus A minus 1 into I. That's it. Because we want to find out that P exclusively without involving P transpose. So here, this is A square P, bring this side. So you will have P into that 1 minus A square. And here A into that A minus 1 into I plus A minus 1 into I. This is equal to, you can take that A minus 1 into I common. Then here one A is left and plus 1. See here A is greater than 1. So A minus 1 is not equal to 0. So this becomes P into here 1 minus A square into P equal to, right side is A square minus 1 into I. This I can take that minus of 1 minus A square into I. Now question becomes simple. So we can cancel this 1 minus A square because that A is greater than 1. You cancel this. So simply we got that P equal to minus I matrix. Here P is a 3 by 3 matrix. So they are asking what is adjoint of P, right? From this, you can find that P equal to determinant of minus I, nothing but minus 1 whole cube into det I This is equal to minus 1. Now what else is left? That determinant of adjoint of A. So therefore, determinant of adjoint of P equal to simply det P whole square. So that becomes 1. So option D is correct. See, you are finding so many questions based on a single concept. That is properties of adjoint of a matrix. So here is a question that asked in June 2022. The positive value of the determinant of matrix A whose adjoint of A is given. Question is asked in reverse direction. Previous questions are they have given adjoint determinant of A value and asking that adjoint determinant of A, etc. But here they have given the matrix adjoint of A and they are asking what is the positive value of determinant of A. So here the simple thing is you take that determinant on both sides. Determinant of adjoint of A equal to right side also you take that determinant. It is 14, 28, minus 14, minus 14, 14, 28. They have given the determinant also in a simplest way without making any struggle. So left side one is determinant of A whole to the power of n minus 1 whole square. Here we have a two determinants. And A is a 3 by 3 matrix. So this becomes that 3 minus 1 whole square. From first row, 114 common from first row, right? From second row, another 14 common. From third row, another 14 common. Here 1, 2, minus 1, minus 1, 1, 2. And this is 2, minus 1, 1. So this implies left side is determinant of A whole to the power of 4. Whereas right side, it becomes 14 cube. And expand this determinant, you will have 1 minus of n. This is 3, minus 1, minus 4, minus 5. It becomes plus 10. This is 1 minus 2, minus 1, plus 1. Nice. So, without making any struggle, it becomes 14 power 4. So, this implies that det A equal to either plus 14 or minus 14. That's it. They are asking the positive value of determinant of A. So another question based on that determinant of adjoint of A asked in June 2022, but by mixing some more concepts, like first they have given some set S equal to set of root n lies between 1 to 50, and they have given n is odd, and let A belongs to S. They have given a matrix A, and another piece of information is sigma determinant of adjoint of A, because determinant adjoint of A involves a variable A, that A belongs to S, equal to some 100 lambda, asking what is the lambda value. So this question involves too many parameters. It seems like that, but in actual, it doesn't. So see, the first point is how to find out the determinant of adjoint of A, right? So the first thing is we write that what is determinant of adjoint of A. So determinant of adjoint of A is nothing but det A whole square. Well, this is over. Now what is determinant of A? So det A equal to, I will write directly. You multiply here 1 into 1. Anyway, middle element it becomes 0. So A into minus here, this is 0 and A. So A into A square. So this becomes 1 plus A square. Once again, here this A into this becomes 0, minus of minus plus A. So det A equal to 1 plus A square. We'll substitute here. So now they are asking that here A belongs to S. So sigma A belongs to S. What is determinant of that adjoint of A? Equal to determinant of sigma of A belongs to S. Here determinant of adjoint of A is det A whole square. Further it becomes A belongs to S. It is just 1 plus A square whole square, where A belongs to an element of S. Alright. Here A square, A belongs to S, right? So you can take that A equal to root n. A belongs to S. So you take A equal to root n, where n is odd. And n lies between 1 to 50. So, which means that here A square is nothing but n. Of course, but n is an odd. So, this is further equivalent to, this is equivalent to, we can write sigma, right? Here you see n belongs to 1 to 50. And of course, n is odd. N is odd. In place of A square, you can write only n. So it becomes 1 plus n whole square. So now substitute that values of n where n is odd. Substitute n equal to 1, you will get 2 square. Substitute n equal to 3 because n is odd. So you will get 4 square. Substitute n equal to 5, you will get 6 square. At last, substitute that n equal to 49. So you will get 50 square. So this is equivalent to, you take 2 square common because these are all even numbers. So you will get 1 square plus 2 square plus and so on. Here this is 25 square. Wait. This implies this is 4 into, now you apply sigma n square formula, that n into n plus 1 into 2n plus 1 whole by 6. So this you will get that this is 25 into 400 into, this is 13 into 17. So you will get 100 into 221. So lambda value is 221. Similar way, you try to solve the remaining questions. Otherwise, I'll upload the solutions of remaining previous JEE main questions also.